Alright, recently we have been drawing a bunch of shapes like this and claiming that they are squares. Now, it's pretty easy to show that the four sides of that shape are the same length using the Pythagorean theorem, but that's only part of being a square. A square has all four sides the same length, but a square also has four right angles. So today I want to talk a little bit about how we know that each of these four angles is a right angle. So before we do that, I just want to mention real quick about what an angle is and how they're measured. So an angle is any time two lines or rays or segments, when they come together, they form a sort of wedge shape or a V shape, however you want to think about it, and that's what an angle is. So it's just two intersecting lines that come together and they form this V shape. Now, the measure of the angle is just how far open they are. So if I have, they're very closed, there's a very small angle. And we open it up to where they are perpendicular. That's a right angle. Right? And I could open it up further, like this. If they meet like that, that's maybe like 135 degrees or something like that. This angle right here, somewhere there, is around 45-ish, right? And then in our class, we're only going as far as angles that are open up 100 degrees, so 180, sorry, so it's open up all the way to they're flat, like a completely open book, 180 degrees, and it just looks like a straight line. In some classes we deal with angles that have bigger measures than that, but we won't here. So this is, remember, you can think of it as the straight line is like two 90-degree angles put together. 90 plus 90 is 180. Open it up all the way like a book, 180 degrees. It's also true that if I take two angles and I sort of wedge them together and they make a straight line down here, then whatever their measures are, like that one's smaller, that one's bigger, but whatever their measures are, however far open they are, those two measures add up to 180. Or maybe down here, I have a whole bunch of angles that come together and form this straight line, then they are all those angle measures add up to 180. By the way, when we're dealing with two in particular, they're called a linear pair, and their measures are supplementary. A couple terms you could look up there. Another fact is that the three angles in a triangle, so two lines come together here, two to come together here, two to come together down here, those three angles always also add up to 180. And that's just something that we accept as true. It's a fact. There's no way to prove it, at least not in our world of geometry. Alright, so these two facts, that the three angles in a triangle, their measures add up to 180, and that a straight angle, completely open, flat like a book, its measure is 180. Those two facts are what we need in order to show that these angles here are all right angles. So here, you'll notice we can take this square and I can nest it right in here, right there. Here is the top corner of it. I'll draw a line up here. And when we formed this square, we formed it by making this pattern from each vertex to the next. So over 3, up 2, up 3, over 2, 3, 2, 3, 2. So from each vertex to the next, there's this 3, 2 pattern. And I suppose we could go the other way and it'd be 2, 3, but whatever. As long as we go in the same direction, it's 2, 3. And we could surround the square with 4 congruent triangles, all the same. Now down here, I have 2 of those congruent triangles. Now, these triangles are all right triangles, and so I've got the right angle down here, and I'm just going to call this angle 1 and this angle 2. So I've got these labeled over here. This is angle 1, there's angle 2. There's angle 1, there's angle 2. Now remember, the three angles in the triangle, they add up to 180. And if one of those angles is a right angle, I can take that 90 degrees out, and I'm left with 90. So there's 90 degrees to split between the two remaining angles. So angle 2, whatever its measure is, however far open it is, its measure plus angle 1, so the amount of openness it has, right? Those two measures added together are going to equal 90, and then if I add the final 90 degrees on, I get 180 for the full triangle. So measure of angle 1, measure of angle 2, add up to 90. But notice, the way these two triangles are wedged in, there's an angle 2, and there's an angle 1. So angle 1 plus angle 2 add up to 90. And angle 1 plus angle 2 plus this angle right here add up to 180 because they make this straight line. So if I take away angle 1 and angle 2, which we know add up to 90, then I'm left with this angle right here, and it must be 90 degrees, or it must be a right angle. Again, 1 plus whatever this angle is here, plus 2, all those measures added together equal 180, and 1 and 2 added together equal 90. So 180, take away these two, take away 90, leaves 90 for the remaining angle in the middle. Again, how did we know all three of these added up to 180? Because they form a straight angle. A straight angle, a completely open angle, its measure is 180. So any number of smaller angles that add up to that straight angle, their measures add up to 180. How did we know that angle 2 and angle 1 add up to 90? Well, because they're in a right triangle, and the measures in any triangle, or the angles, they add up to 180. In a right triangle, one of those angles is 90. I take it away, and the remaining two have to add up to 90. They might be bigger or smaller, but altogether they add up to 90, so that when I add that right angle in, I get 180 total, and every triangle has angle measures that add up to 180. And that gives us, again, the straight angle here is formed by these three angles, 1 and 2, the one that the arrow is pointing at. 1 and 2 add up to 90. Take 1 and 2 out of there. That leaves us with 90 remaining degrees, which must go into the angle that has the arrow pointing to it, which means that in this square, that must actually be a right angle. And I could just rotate the square around to make the same argument for all of those angles. So that's how we know it's a square. Now you know.